In this unit, let's talk a little bit about color and gel. Right, so below here are some samples of gel. And what all a gel does is take the available light that comes into it and filters out all the colors we don't want and lets only the color we do want to pass through. So if you'll look, there's a little spectrograph that is underneath of each one of these color swatches. And you can note that our red, R26 here, right, is going to pass most of the red spectrum. These shorter, faster wavelengths is what it's going to pass. And it will absorb the blue and the green. Our green filter is going to pass most of our green frequencies, which are in the middle of our spectrum, and filter out both the red and the blue. Now, our blue filter is going to pass much of the blue frequencies and pass a little bit of the extreme red frequencies, way off to the edges of the red. You'll note the same is true of our cyan. It's going to pass a lot of the blue and then even some of the green through here and a little bit of that far red. Magenta, you can see the same thing. So these graphs that are inside or underneath of our gel swatches actually give us an indication of what frequencies of colored light are going to pass through that filter. Now, the red filter is going to absorb everything except for the red light. And a blue filter is going to absorb everything except for the blue light. And a green filter is going to absorb everything except for the green light. A gel filter can only pass a color if the light source is providing it. So if our light source has a complete range of color, then it can pass any part of that spectrum. But it's really dependent on the source being able to pass it. What if we were to shine only a green light at a red filter? No light would pass through that filter because this red filter is only going to allow red wavelengths to pass through. If we were to shine a magenta light, magenta being made up of blue light waves and red light waves, at a red filter, it's only going to pass the red light. It's an essential concept to understand that the light source and the colors produced by that light source are really an important part of your gel color selection, right? So we look at it one more time. If we were to shine red, blue, and green light at a magenta filter, it's going to filter out or absorb the green and pass just the blue and the red. It's going to just pass that color, right? So we talk about the source and its color, right? And we've talked a little bit about color temperature being a measure of how warm or cool a light source might be in degrees Kelvin. And the color of our light source now becomes very important because the color of our lamp is really going to affect how well our fixture is able to produce a gel color, right? So let's look at a spectral analysis here. So if we look at daylight and the composition of daylight and intensity, you can see that this is a fairly complete curve. It's a sweeping curve. It's a little low on the red side, and it's really low on the ultraviolet side, right? So, but this is the visible spectrum of daylight, right? And you can see that daylight at noon lives in this 5,500 degrees Kelvin and provides a fairly balanced spectrum. Now, if we move into an incandescent light or even a tungsten light, you can see that our spectral analysis has changed. An incandescent light is much better at producing red light energy and not nearly as good at blue light energy. An incandescent light bulb usually lives in the 2,800 to 3,500 degrees Kelvin right? Which is warmer along our degrees Kelvin scale, which means there's more red energy than there is blue energy. Most stage light lamps are listed at 32 degrees 100 Kelvin, which is right in here. And so now let's move on real quick. All right, so that's our daylight graph, and this is our incandescent graph. What about fluorescent light? Oh, fluorescent light. Very jagged, very broken, a very incomplete spectrum. There might be a reason why you dislike fluorescent lighting. And my question is, how many costume shops and how many paint shops are lit with fluorescent light? If we remember the idea that it takes a light wave to be available in order to be reflected, how well do my red tones and blue tones and subtle green and cyan tones, how well are we actually reflecting accurate color, especially once we move a drop or a costume to the stage? I wonder what could possibly go wrong. I'll be back in a minute and we'll talk about LED.